Okay, so the last section we have to look at is the common and natural logarithms. Okay, these are very special logarithms. Okay, they show up a lot, which is why they're called common and natural logarithms. For instance, the common logarithm, okay, log x is how it's written. This is the common log, okay, and it means log base 10 of x. Okay, so when there is no base specified, and you might want to make a note of this, when there isn't a base specified, we assume it to be 10. Okay, so when there is no base specified, so I kind of briefly mentioned this in the last lesson, but when you don't have a base written, okay, then we assume it to be 10. So what that means is that when I'm going through and working these problems, okay, log of 10 means that there is no base. I mean, it means that the base right here has got to be 10 because they didn't write a base down. The reason why it's called a common logarithm is because it is very common, because all of our number system is based on 10. Okay, we count by 10s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we kind of start over, 11, 12, 13, 14, 15. So we just keep reusing that 0 to 10 kind of thing, so, or 1 to 10. So that's why it's a base 10, that's why it's called the common logarithm. It's something that's used often, so they just decided they didn't want to write the little base 10 anymore, so they just dropped it. Okay, so anytime there isn't a base, we just call it 10. So this right here, find the exact value of each logarithm. So what is the log of 10? What are they asking me for? Well, what they're saying is log base 10 of 10. Okay, and we can just set it equal to x, because that's what we're trying to figure out. What is it equal to? So I can convert that. 10 to the x power is equal to 10. Okay, so 10 to what power gives me 10? Well, x has to be 1. Okay, this goes back into that mental math. This whole thing is non-calculator, so it's all mental math. Okay, but it's going to be 1. I could have also noticed that here, when my base and my argument match, that's one of my special properties that I must know. There's 3 of them. Okay, but my base and my argument match, it's equal to the exponent. Well, what's the exponent when it's not written? 1. Okay, so if my base and my argument match, it's automatically equal to 1. Okay, so x is equal to 1 there. So same sort of thing here, log of 1,000. Okay, it seems hard. It's really not. Set it equal to 0 and convert. What's my base? Okay, this is the Snell thing. Only I know my base is 10. So 10 to the x power equals 1,000. Okay, well 10 to what power gives me 1,000? A lot of people think 10, but 10 to the 10th means there would be 10 zeros. Okay, 10 cubed would give me 1,000. Okay, you got to imagine 10 times 10 is 100. Times another 10 is 1,000. The quickest, easiest way is just count the number of zeros with these. There are 3 zeros, so I need x to the 3rd power. 10 to the 3rd power is how I get 1,000. Okay, so x is equal to 3. So same thing here, log to the 1/10. So we've already discussed all of these properties. If I want to make a fraction happen, okay, I still have the same process. So 10 raised to the x power is equal to 1/10. Okay, well, x has to be, it's going to be 1 because 10 to the 1st power is 10, but how do I make 1/10? I make it negative. Okay, remember that negative, it's supposed to say -1, not -10. I'm saying 10 too many times. Okay, 10 to the 1st power would give me 10, so 10 to the -1 drops it to the bottom. So 10 to the -1 gives me 1/10, thus x has to be -1. Okay, so same thing here. I can rewrite this log of 10 to the 1/2. Okay, I can either use my special properties here, my base and my argument match, because my base is 10 and my argument's 10, so it's going to be equal to 1/2. If I don't like that, set it equal to x. And I get 10 to the x power equals 10 to the 1/2 power, so x has to equal 1/2. Okay, so either way it goes works. Okay, so hit the pause button, see if you can get this on your own correct. Okay, come back and see if you're right. Okay, so when I do this, I get 10. If I set this equal to x, I get 10 to the x power equals 1 over 100. Okay, so I have to figure out 10 to what power gives me 100? Well, 10 squared. So I know x has to be a 2. and I want a 1 over 100, so to make it flip, I drew a negative. 10 to the negative 2, and I'm going to write this up here just so you can see this. This is what I'm saying, 10 to the negative 2, okay, which is the same thing as saying 1 over 10 squared, which is the same thing as saying 1 over 100, because 10 squared, that's a square, 10 squared is equal to 100. 10 times 10 is 100. So that's kind of what we're looking at here. So x is equal to negative 2. Now, that's the common log. The natural log, and this is the one that confuses people the most, but it's really the same sort of idea. The natural log of x means log base e of x. Okay, so in nature, there's a particular thing that shows up a lot, and it's e. And it's important you know that e is a number. Okay, it's not a variable. It's actually a number, kind of like pi has a value. 3.14, blah, 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 blah. Okay, e has a number. In fact, I'll tell you what that number is. Admittedly, I don't know the exact number, so I'm going to use my calculator for 2 seconds to give you a more accurate answer here. As soon as I can find it on my calculator, you can tell I don't do these as much. Okay, I usually just work them in my head, so I can't always find them. Okay, so it's 2.718. Approximately 2.718. Now, you don't need to know this number, okay? I'm just kind of writing it down there just to let you know that it is a number. That's super important, that it's not a variable. It's not something I can solve for. It actually has a value, okay, because that's going to make a difference. So, the base of a natural log is e. Okay, the base of a natural log is e. So what does this mean to me? Well, think about stuff like this. The natural log of e. Okay, what's the natural log of e? Well, it has to be equal to 1. Why? Okay, because this right here means log base e of e. Okay, if you look at the properties, that means my base and my argument match, so it's going to be equal to the exponent. When that exponent's not written, we just assume it to be 1. Okay, so the natural log of e is 1. For that matter, if I have e raised to the natural log of 1, okay, well that's the same thing as saying e to the log base e of 1. And when our bases here match, that's another property. These two bases match, it's equal to that argument, so it's just 1. Okay, so those are two important things to remember. They just go back to the other properties. So if you know the other properties and you understand that the natural log is just a log with base e, okay, then it should be pretty simple because it's not anything new, it's just understanding it. Alright, so let's take a look at some of the examples. Find the exact value of each natural logarithm. So if I want to find the exact value, okay, well the natural log of e to the third power. Well, base and argument match, because the base of this, if you need to write it out, do it. Okay, you don't have to leave it as the natural log. If you really have to write it out, log base e of e to the third, it's just 3. Okay, I'm not going to keep writing them out, but you can if you need to. If you don't like the natural log notation, change it back to log base e. Okay, so here, natural log of the 5th root of e. Well, that's the same thing as saying the natural log of e to the 1/5. Okay, so base and argument match, so it's just equal to 1/5. Okay, so same thing here. Now this one's a little more difficult because what I'm looking at is e to the 2 times, and I'm going to have to zoom in yet again for this one. There we go. So I've got e to the 2 times the natural log of x. Well, I can't do anything with it like this, okay, because it's going to be equal to the argument, but then what do you do with the 2 out front? So instead, I don't like to work with it like that, so we're going to take that 2 and we're going to move it back to the exponent spot. This is the power property. It still applies here, so I get the natural log of x squared. Okay, so now I'm looking at e, and instead of 2 times the natural log, I've got the natural log of x squared. Well, now if I look at these properties, my bases here match. Okay, because e raised to the, that means log base e. of x squared, so it's just equal to x squared. Okay, because it's equal to the argument. Know those properties. Those properties are essential. Okay, you cannot pass this test without those properties. Now, hit the pause button, try this on your own. This is a really good one. You really want to try this. Make sure that you're getting the correct answers. Make sure you got the concept down. If not, go back through, watch the video again, see if you can do it. Okay, so hit pause, come back. So the natural log of e raised to the x plus 2, my base and my argument match, because here this is the same thing as saying log base e of e to the x plus 2. Okay, so when my base and my argument match, it's just equal to the exponent. So it's just x plus 2. Okay, that's just using properties. That's all I'm doing. I'm just using these properties over and over and over again. Okay, there's like 3 particular properties that we're going to use a lot of. Okay, there's 3 particular properties we're going to use over and over again, and I need you to go back and make sure that you memorize them. Otherwise, this unit's going to get really hard, but it doesn't need to be. All right, so properties. Okay, the properties are the same with the natural logs. Natural log of x times y is equal to natural log of x plus the natural log of y. Natural log of x divided by y is equal to natural log of x minus the natural log of y. And the natural log of x to the r is equal to r times the natural log of x. Okay, so the properties are going to be the same. Okay, so you don't have to like learn 3 new properties. These are exact same properties, only now it's just got the natural log in them. Sorry about the pause a minute ago, by the way. They were screaming outside. I was trying to figure out what it was. So, okay, back to this though. Don't go and memorize the new they're the same properties. You do need to memorize the properties, but it's just the same 3. So don't feel like you're getting overwhelmed because there's so much to remember. They're the same exact thing, only these are log base e. Okay? So when I go to put them together, they act exactly the same way. The natural log of 8 plus the natural log of 2. Well, when I'm adding, okay, I multiply arguments. So natural log of 8 times 2, which is just the natural log of 16. Okay, that's your answer. So here, when I'm dividing, or when I'm subtracting, I divide arguments. So the natural log of 24 over 4x. Okay, we'll reduce that. 24 over 4 reduces to 6. Be careful, though, that x is still on the bottom, so I get natural log of 6 over x. Here, same sort of thing as the last section. Okay, before I can start putting these things together, those numbers out front must move to the exponent spot. So I get the natural log of 3 squared plus the natural log of 4 minus the natural log of 2 squared. Well, this is the natural log of 9 plus the natural log of 4, so 9 times, that's the same thing as saying the natural log of 9 times 4 minus the natural log of 4, because 2 squared is 4. 9 times 4 is 36. So that gives me the natural log of 36 divided by 4, which is just equal to the natural log of 9. Now be very careful here. I've seen a lot of people just writing 9. Okay, it's the natural log of 9. Okay, I haven't solved anything yet. I haven't solved anything, so you have to leave it with the natural log. Once you solve and we find like x equals something, then you can drop the log. But until then, you have to keep that log there. So hit the pause button. This is the last one of this unit. Try it. See if you can do it. Come back and check it. I'm going to keep on going. Okay, my number up front has to move to the exponent spot first. So I get the natural log of 2 cubed is 8 plus the natural log of 5 minus the natural log of 4. Okay, when I'm adding 2 logarithms, I multiply their arguments. So I get the natural log of 40 minus the natural log of 4. Okay, and then the natural log of 40 minus the natural log of 4, so that becomes division, natural log of 40 over 4, which is the natural log of 10. By the way, the natural log, this actually says ln. A lot of people think that says I, but that's an ln. This is a lowercase l and a lowercase n. Okay, that's the natural log. I believe it's it comes from some other actual language, German or French or something along those lines is the reason why there's an LN and not an NL for natural log. So, if you were curious. All right, and that's that. So, again, that's the end of this unit. The big part is to go back and learn these three properties: product property, quotient property, and the power property, as well as the properties in the very first unit. And I keep saying this at the end of every single unit, is you need to know the properties of logarithms. You just have to know those properties. Okay, so you've got to know the three ones that I keep referring to as the special properties. Okay, go back and learn those properties. There's 6 of them. Okay, know all 6 properties. Good luck.